introduce you, Michael, the territory account manager at WEG Electric. He's been there since December of 2018. He has over 13 years in the industrial VFD and electrical motor business. He's got a degree from Triangle Tech and also spent some time at ABB. So he's going to be speaking to us today about monitoring critical motor applications. So Michael, I will just go ahead and just turn it over to you. It looks like you're already sharing and I can see it, so I'm assuming everyone else can. And we'll just go ahead whenever you're ready.
Great, sounds good. Can everybody hear me?
Yes. I can hear you just fine.
Yep. All right, thanks, Drew. Thanks for inviting me to participate. So the company's name, it depends on where you're from. We'll pronounce it WEG here in the U.S., but we're a Brazilian company, and there are many Germans that live in the Brazilian area and work for the company. So sometimes they pronounce it WEG with a V. So it just all depends. So we'll jump right in here. So monitoring critical motor applications and Industry 4.0. I'm hoping I don't put everybody to sleep right after lunch or during lunch here. So I'll try to make it exciting. Sometimes talking about Industry 4.0 and big data is not all that exciting. Let's see if I can get this to work here. I don't see it changing on the presentation here. Sorry about that. Let me see if I can get this to work again. There we go.
Yep, there it goes.
All right, perfect. Okay, so we're currently in Industry 4.0. So if you go back to the, this is a layout of what the different industry segments have looked like. Starting in the 18th century, things were powered by, steam. Mechanicalization was just kind of beginning. You move to Industry 2.0, where there's more of a mass production assembly line. Electrical energy was introduced. DC energy, which changed into AC energy as the leader. When you come into Industry 3.0, you see more automation, computerization being used, more low and high power electronics being used. And then we move into Industry 4.0. You may have seen, the Internet of Things, IoT 4.0. There's all kinds of different, systems being implemented to kind of tie all of your critical applications and equipment together. So this is kind of an overview of Industry 4.0, what's included within that, what does it look like? And kind of sum it up, it's taking, your local integrated systems, enhancing those systems, or, more folks are coming up to speed and introducing integrated systems on a factory or a plant level. And then it's really communicating with the cloud. Taking data extrapolated from these integrated systems, and using big data analytics to try to anticipate when something's going to fail, to kind of have an idea of what kind of maintenance schedules you need to have in place, or just to have real-time alerts. SMS communication. If you're not in the field, if you're back at the office and you've got a piece of equipment that can alert you when something is not optimally running, that's all tied in with Industry 4.0, making it easy to know what is happening with each of your pieces of equipment in the field. So that's where I'll segue into the WEG motor scan. So this is a small device, and we're going to specifically talk about electric motors. ranging from various horsepowers, and this will be geared towards a cast iron product, where this will be mounted right onto the frame of the motor. But this device is used. It basically monitors the motor's temperature and vibration and running time to use that data to basically create a trend for your maintenance personnel. And what this will do is it allows you, what I like to call it is basically a Fitbit for your motor. What you can do is you install a new piece of equipment with a new motor. You can install this small device, and then what it'll do is you can take an initial reading while it's running. Hey, this is the current skin temperature. This is what the different axes of vibration look like. Let's check it in a month or 2 months and see if that's changed. And then you can trend it over the lifespan of the motor. And if you see vibration limits or a temperature is increasing, then that's when you can allocate time to that specific application, that specific motor, to really try to get ahead of any type of issue you may see. I mean, an issue, what I'm talking about is a failure, which is downtime, which is productivity, which is critical for midstream pumping applications, reciprocating compressor applications. I mean, if it stops, the motor has to be pulled off and evaluated, and sometimes completely reworked depending on the type of failure. So what does it look like? So again, I mentioned a cast iron motor. So you'll see here the motor has little cast iron ribs, and this thing mounts right onto the one of the ribs. So how do we extrapolate the data from this tiny sensor? We can do it via a smartphone. Android and Apple platforms are acceptable. You can download an app. And what you're able to do is when you use the sensor, you've got to be within a certain perimeter, and your cell phone, you can upload the data via Bluetooth to your cell phone, and then it uploads to the WEG service cloud. And what you can do from there is you can then access from our IoT platform, which is a web-based software. You can access it to trend your data. The data is saved in the cloud for you. So how does it work? There's two different ways. We talked about using a smartphone to extrapolate the data from the sensor, but you can also utilize a gateway. So wirelessly, we're able to pull the data from the sensor via the gateway, and it uploads it to the cloud, or we can do it via the phone app. Again, it's stored in the cloud. Real-time analysis may be done directly on the smartphone while you're by the actual sensor. And again, the data is stored right in the cloud there for you to be analyzed at a later date. So here's what the sensor looks like. We list some motor frame sizes. I don't know if these are familiar to you folks, but you're typically talking up to about a 1,250 horsepower motor. We can utilize this sensor mounted onto the rib. Vibration monitoring is in 3 different axes. Temperature, running hours, battery power is about 3 years worth of life. You have a very large swing of ambient temperatures that this thing can be utilized within. DOL and VFD starting. There's a lot of applications, especially in the midstream market, that are how the motor is actually powered and used, and speed may be varied for different process points, whether it's a pumping application or a reciprocating compressor application. This sensor can be used for that type of starting method as well. Installation's very easy. You basically drill a small hole into the rib. There's a little piece you tap into the rib itself, and then you attach the sensor via a small screw right to that device, and then from there you can download the app to your phone, and then you register that device. You can name that device and start using it right away. The installation can be done in the field. It can be done by a local motor shop. It can be done by the manufacturer, before the motor is actually shipped. So, no issues there. Again, the app, instant measurement features, frequency spectrum measurements. You can have a 2-level alert system where it'll alert you, hey, there's a critical issue. There's a warning, and then it moves to a critical issue. So you can kind of be on top of what's happening in the field. Again, there are some real-time alerts you can set up. You've got to use the wireless gateway and have it configured to do so. I think most end users really see value in setting up a plan for their maintenance personnel to go around, and as they're doing their daily routines, and just uploading the data once a month so they can track it and evaluate if they need to make a change or have somebody evaluate the product. So here's what the app looks like. You can see here, if you allow it, it'll actually show you the location of your motor via GPS. Here's the data here, what it'll look like in real time. And then here you can see it'll list, hey, I've got, you can name it pump A, pump B, compressor 6, whatever you want to name it, so then you know which is which. Again, this data is stored in the cloud, so you can access it, from a web portal. Pull up the data. You can trend history. And we store the data for you. And here's just some screens that'll show you some different features where we'll track the different vibrations, whether it's radio XY, whether it's an axial vibration. We'll estimate speed, temperature, and there's even some ways to insert, well, how loaded is the motor, which are some calculations. You're able to edit tolerances and edit how your graphing looks, if you want to get that intricate with the details. And they'll even give you some suggestions within the platform, the IoT platform. Hey, this is the vibration level that the sensor's reading. This is what you may want to check in the field. And there's a couple more screenshots. Again, the vibrations, the temperature of the skin of the motor is listed here. And again, at the end of the day, it's not really to really extrapolate all of this data and just look at it. It's really so the maintenance personnel can really look at this and say, hey, we need to grease the bearings in the motor, or is there something outside of the motor within the environment causing an issue? Excuse me. Whether it's an environmental issue. There are some applications. I'll go out into the field. I'm going to pick on a paper mill. Those guys are notorious for torturing motors. What I'll find is sometimes the pulp, the wet pulp used to make paper, will fall onto the motor, into those small ribs, and then dry, and then basically turn into almost like a concrete is what it looks like. But what that does is that puts a blanket over that motor, and your temperature increases. So this sensor is able to evaluate that data and potentially alert somebody, hey, this motor may fail. And some motor products are not available off the shelf from a distributor or from a manufacturer. Sometimes it's a very highly customized product, which could take 10, 12, 14 plus weeks to get a replacement for if it's not repairable. So it's really linked to uptime which equals productivity in the field. And it gives a good base, especially nowadays when you have maintenance personnel and that are being numbers are being reduced of how many people are being deployed into the field, and that you've seen that trend, not even during or post COVID. It was pre-COVID where folks were wearing many hats, trying to get 2 or 3 people's jobs done where they were typically doing one person's job. And this is a way to help manage their critical applications. I wouldn't use this on every single motor in a facility. Maybe different midstream sites. There's a certain amount of motor applications where it's critical that they've got uptime is of the utmost importance. If they do not have a spare motor, or even if they do have a spare motor, some of these larger machines, it's not a matter of, hey, in a half hour we'll have the motor pulled and we'll have a new one in. No, it could be a whole day, depending on the size of the motor, where the spare is. Do you need a new coupling? And on top of that, the cost of that day of being down and the maintenance personnel, their time being allocated to that piece of equipment when they could be doing something else within the facility. So really, you want to sit down and look and say, well, which applications are most important? Where am I making the most money? And we can't afford to be down. So this slide here, we show device compatibility. It's a little old. We have here motor condition, balance, misalignment, bearing condition. We're able to do some of those things today. There are some of those features which I believe might be misalignment that are future releases. So some of these are available today. So again, I think I touched base already on the value to the customer, but there's value not only to the end user or maintenance companies, but it's a real value for the original equipment manufacturers that are specifying equipment for the midstream sites. It's important for them to understand the importance of maintenance, and helping the end user to make predicting maintenance as easy as it possibly can. There's 3 main things that are really critical when it comes to a motor application. One is sizing it appropriately for the application, which you could spend a whole day discussing that, how to do it, and all the different applications, which we're not going to do today. The second one is, okay, well, the environment that the motor is going to be installed in, you got to make sure that mechanically it's designed to work within the environment that it's going to be installed. Like I mentioned before, you've got a paper mill, which can be a very nasty application. Steel mills, that's a very nasty, dirty application. You have to make sure the enclosures was able to handle that. And when you get into the midstream market, you've got a lot of areas where there are potentially hazardous explosive areas. So the motor has to be what we would call Division 1 or Division 2, UL or CSA classified. So you get into all those kinds of things too, the nitty-gritty details on the environment. And then the third really is, okay, well, once you get the thing, you got to maintain it and make sure that it's running properly. Vibration, greasing the bearings, making sure that the motor's clean, so you're not increasing the heat within the motor, because a motor, everything's thermal. The majority of failures are either a bearing failure, which is a lot of times due to heat, or contamination. So it's all environment and application of the product. So that third bullet is where I would lay the WEG Motor Scan product, is really to help drive maintenance. Data security. So we get this question a lot. When utilizing the gateway, a question that arises is, well, okay, well, you're transmitting this data, and even though it's not necessarily personal, really important data, can the data be hacked? What we're doing is the data that's actually being transferred from the sensor to the phone is actually coded. So if somebody interprets it and tries to read the data, if they really want to know the vibration of one of your electric motors, they won't understand the data, because until it hits the cloud, it won't be uncoded. And I don't profess to be any type of coding expert, so I'm not gonna try to dive into that. But we are putting protection into the data, because that is a big question, especially nowadays. That's such a hot button issue is how to protect the data. So we've got a bunch of online resources. We have a landing page, which has more information than anybody probably needs to be able to access for this product. And I will share that. I'll share that in the chat link, so everybody can have access to that. So, and that'll be it for my presentation here. Again, I just want to thank everybody for sitting through this day one of the conference. I think all of the presenters, I sat through all the presentations. They're all very good. If you've got any questions now, let me know. If you don't have any questions now, but you do in the future, about the WEG motor scan or any other WEG product, just let me know. I've got my contact information on this last slide.
Well, thank you, Michael, for the nice comments about the conference. You may have covered this. I'll go ahead and ask one question, and we can hopefully some others chime in. But how does retrofitting with this product work? Or is it possible? Is it an option?
Yeah, absolutely. Our sensor can be used on any a brand of motor, any manufactured motor, as long as it's cast iron and it has a ribbing on the frame. So again, what you can do is you can drill a small hole into one of the ribs. It has to be a certain distance from the what we would call the opposite drive end or the fan end of the motor. You kind of want to be there's a certain distance in the installation manual. You drill a small hole, and then you're given a small bushing that's gnarled, and then with a hammer you can tap it into that small hole. Then take the sensor and a small screw, and you just screw it right into that bushing that you installed into the frame of the motor. And I think we have a video on our website that shows. I mean, it can be done like in 3 minutes. It doesn't take too much time to actually install the sensor. And again, you can do it in the field. Somebody can do it for you, or before the motor is purchased. If it's a WEG a product, then we'll actually modify it for you. We'll install the sensor and then ship the motor to you with the sensor already installed.
Okay, so a follow-up on that question. I don't know if you saw it come in on the chat, but I'm assuming for the WEG motors, it wouldn't void any sort of warranty. But if you were doing it on a different manufacturer, would that void the warranty?
Yeah, that's a good question. I've not had that question yet, but yeah, that's a good point. If it's another manufacturer, if you install the sensor, since you're actually modifying the frame, I'm not sure if so. Most of the failures. So the point where you're going to drill the hole, it can't access the internals of the motor. So if it's just on this piece of cast iron that's protruding from the frame of the motor, I mean, you could drill a bunch of holes in there if you wanted. You're not going to affect the performance of the motor. And what those little fins are, those cast iron fins, those are to help dissipate the internal heat that's generated from the motor running. But drilling a hole isn't going to damage the thermal dissipation capabilities of the motor, no matter whose brand it is. So I would say if somebody drilled a hole in the frame and they drilled it into the inside of the motor and damaged the winding, that would be a warranty issue. But I wouldn't see having our sensor or somebody else's sensor mounted onto somebody's motor causing any type of warranty issue.
Okay, thank you. Anyone else on the line have questions for Michael? Okay. Well, we may not get any more questions here, Michael, but that's fine. People, for those that have been on most of these calls today, you know, people are probably getting worn out. But we do appreciate your time, Michael. Thanks again for the presentation here. And